I can select latent variables. I can draw them, right? Again, if I want to go to different thing, I can go to select. Then I can have these connections, right? Like this, you can do it. Can you try this? Linking and having these circles, we call latent variables, and the connectors you can have. Can you develop this model, which I have developed now? This model. You can see left-hand side, you can see there are a lot of variables, but you have to only select these variables, right? I assume this is a different model data set, but I gave the label, one is corporate social responsibility or something, right? The other one, customer loyalty or something, right? Assume one. But this is a different one, but for the exercise, we can do that. The other one, let's say performance. Here, there are several indicators, measures for corporate social responsibility. Then you can select these things with the shift and you can write drag. Then you can create this particular latent variable with the manifest variables or the indicators. Same thing you can do with 3 items of customer loyalty. And also performance also, there are 5 indicators. Can you try that till others join? With this, we can work today rather than the data set which I email you, right? I think here there's a good data set. We can develop hypothetical model here. Is it clear, Lalit sir?
Yes, Dinesh. Now I think this is better. We can remind what we have discussed in the previous session.
Yes.
Yes.
You can draw this model, see whether anyone who cannot draw this model, anyone who missed that one, right? Very simple, right? Graphical exercise you have to, right? You can select this one, right? Latent variable. Then you can click here, right? On the canvas. First you have to go to select. Then you have to go to this one, right? Latent variable I selected. Then you can see that is highlighted. Then click on the canvas, right? When you click one, only one circle is created, right? Another one you can create, right? When you click once. Likewise, you can create that. Now I have created, right? You can do the same thing. Then if you select one and if you want to again avoid this creating, again go to select, right? Then if you want to delete one thing, you can select this and click the delete button, right? Likewise, you can do very simple operations. If you want to rename this, select this, right click, rename. Then you can give particular term here, right? What do you want? That way you can create the latent variables.
So here we have to deal with different data set now.
Yes, that is in the student version. It's their pre. What do you call this? PLS SEMBOOK corporate reputation extended. Here there is 344 data set as well as 99 records.
It is immediate, no?
Yes, you can click on this and right click. 99 data set. You can select, right click, create new path model. Then you can get something like this canvas. I have already created that, right? You can get canvas like this. On this, you can make it. Select. Like this, you can make it. Then you can rename. After that, you can simply drag, right? What you want. Now, I want to say, I put this as, let's say, yeah, there are a lot of variables, but I need only the simple model which I mentioned, right? Not all the variables. I need only 3 latent variables here. You can see the model I had drawn, right? Same thing you have to draw. One is CSOR. I will assume this is corporate social responsibility or something, right? Not that meaningful, but for the exercise, we can do that. Here you can see for that there are several indicators, right? Whereby you can identify, right? CSOR 1, 2, 3, 4, 5. There are 5, right? There are 5 indicators. First, I want to give a label to the particular construct or the latent variable, right? I click on this, right click, rename. I give okay. Then I have to simply select one, then click the shift. Hold in the shift, you can go down with the arrow key, right? Up to the 5th one. Then that is all are selected, simply drag that, right? then you can do it. Similarly, you can do other three as well, right? This is what we discussed last time, how to draw it, right? Then I mentioned by default, it's coming reflective models, right? Reflective measurement model here, this for this particular construct. Why I'm saying reflective, you can see the arrows from the latent variables, right? Arrowheads are directed towards the particular indicators, or we call the observable indicators, manifest variables, right? You see, by default, that's reflective. But if you want to make it formative, arrows headed towards the particular latent variable, right? You can click on the latent variable and you can see here, switch between formative, reflective, right? That you can do. As I mentioned, PLS allows you have it both, right? You can have reflective, you can have formative, or in same model, you can have both, right? That's there. But in AMOS, you can see you are having reflective measurement model, right? This way you can see in AMOS. And I mentioned the advantages of PLS. One thing is about even you can go with a small sample, maybe around 50, might be possible, even less than 50 also, okay. But a lot of research says that at least 50 you need for better predictions. And the other thing is you don't have to fulfill the parametric assumptions, especially normality, right? Bell-shaped distribution you don't need. But AMOS you need to fulfill these things, and big sample size 250 or 500 for AMOS. But here no such. Therefore, these are some of the reasons for you to select this PLS over AMOS. And also this is good for exploratory models. But in what you call AMOS, you know that you have to look at sort of what you call model testing, theory testing, right? Very much confirmatory driven, right? Theory testing. But here we can do like even new theory building and exploratory investigation. That means still the relationships are not yet confirmed in the theory or the literature. But with some backing, you can try to see new relationships. We call exploratory, right? We can see new relationships and now emerging models you can try. That's why we say exploratory model, right? It's more exploratory. Then if you have any clarification, you can ask.
Sir,
Yes.
one issue, when I create that path model, in the indicator pane, there's a message saying the current data file contains too many observations. You must upgrade to a professional license if you want to use it. So the variables are not showing.
That's why you have to select this reduced data set.
Yeah, I use that, sir. But for that also the same message appearing.
You reduce data set 99. You have to select that, right click, create a new path model.
Okay.
Try again. I don't know whether you have selected the wrong one.
No,
Above
so
that, there is the other one. 344.
No, I use the 99 record one, sir, but still the variables are not showing for me.
We will see again. You can see. You did this process, no? Create new path model. Then you get the canvas.
I get the canvas, but to select the variables, indicators are not showing. The message is appearing in that pane.
Can you again close that one and do it?
I tried that as well, sir, but nothing changed. The same message is appearing several times.
What's the message?
The current data file contains too many observations. You must upgrade to a professional license if you want to use it.
It says that you are having more than 100. In that case,
but I use 99 records one. But I will try again, sir.
Yes, it is not possible. Again, see whether, right?
Sir, I also get the same message, sir.
Others, Lalisa, you got the 2 people have got that issue. Lalit sir, can you hear me?
So I'm fine.
Yes.
So-
2 people have got that issue. 99
Hmm.
records.
I don't get any error message or anything. So
When you double click on this, do you see its sample size 99? See whether it is shown.
Yes, sir. When I double click on the reduced dataset file, all that indicators, everything is showing on the left hand side, but in the right hand side, indicators are not showing. No indicators to show. It
The
says.
sample size is 99.
Yes.
99.
Yes.
what about others?
Others, yes. 2 people have got the issue.
Yeah. In my case, no problem.
Shogamis is there, no?
Dinesh, I use my data set, not what you asked to do.
But I don't know why.
Dr.
I
Nuwan,
think, yes, Dr. Nuwan also has the same issue.
Is it set 99 records?
Yes, sir.
Then can you go down? Can you see more than 99 here? No.
No, sir.
It shows 99.
Yes.
Then are you on internet? No, you are connected, no?
Yes, sir.
so I tried another time. Still, it's fine.
Yes, yes.
I don't know why.
Another thing is you can again install this one. See whether any issue. I don't know. Like today you installed that or last week?
No, sir. Last week also I participated.
Hmm. Then another option is again close this one.
Okay.
Then you can see this. You can delete this one.
Okay.
Again, try to do a new one.
All right.
And even you can close PLS and again write open PLS. Even go to that level and see whether.
Okay. Sir.
Right. For others, then you can see now, you can draw this model. I think you have drawn this model, no, Lalit sir?
Actually, I did not do, but now I can do that because I was searching in this problem and
I think you can draw this one and link, connect.
yes, I can do that now.
Now I assume hypothetical model. One is independent variable.
There are 3 variables. No?
Yes. Yeah. Though it is not theoretically sound, I just hypothesize. Corporate social responsibility or something, I might say the first one. Independent variable. Then I have dependent variable, the performance or something, let's say performance. In between, I have, according to my conceptual framework and literature, I assume customer loyalties, they are in between. Therefore, I have in my mind a mind model this as a mediator. You see this as a mediator, customer loyalty, CUSL. Now, this is the model we have. Independent, mediator, then dependent variable. Now, today I want to discuss something relevant to mediator test also. Therefore, I will go to that. While we are doing that, you can understand other things also. Last week we discussed, there are 2 models. One is the measurement model, right? Outer model, we say that. Outer model includes, including when you run the analysis, these factor loadings, and also other, what do you call the significance level of each factor, and also look at the convergence validity, discriminant validity, those things we discussed last week in the outer model. After that only we come to the inner model, or we call it structural path model. That means the main arrows, right? Your hypothesis. Then you can see the two models, we have to evaluate them. Therefore, I go to, now you can see the model. I assume all these models are reflective, right? For the moment, reflective. But if you want to hide these things, right? Even this, sometimes when you present the final model, you want to highlight these, what do you call, observable indicators, or what do you call this, manifest variables. Simply you can click on the particular, what do you call, latent variable, and you can say there is particular things to hide this, right? You can see somewhere here, hide indicators. See here, hide. If you want, you can hide. Anytime you can get them, right? That is also there. Show indicators. Any model you can do this. But when you run the initial model for the measurement model, validity reliability assessment, you can show all these things, right? Even you can show the direction also, right? If you want, you can have them on the top like this. You can do this, right? Clicking, there are a lot of options. See whether, right? That is possible. Then you can see this model. Then now I have one independent, dependent, and also mediator, right? I assume you know the mediation, right? In a conceptual framework, right? That means corporate social responsibility is having a direct relationship with the performance, let's say in the organization or product or something, right? Brand, company. Then in between, there is another one is coming to strengthen that relationship. Maybe you can say customer loyalty. Therefore, we have an interest in testing whether this corporate social responsibility and the performance relationship is mediated or they intervene by another variable, right? In literature and hypothesis, if you have developed something like this as a mediator, you can draw this model. Now, my worry is about whether this is really mediating or not at all mediating, or partially mediating, or fully mediating, right? These are the issues we have when you look at the mediation. I think you might have read Baron and Kenny's particular steps also. Some people might know that, right? 1986 article, if you read on the Google Scholar, Baron and Kenny, they talk about there are 4 steps to test the mediation in a model. Those things we can follow here, right? When we do the particular mediation. Before that, I will go to calculate. Now I have created the model, right? I go to calculate here. Very simply, I want to go to, now here there are 2 types of things. One is PLS algorithm, the other one bootstrapping. When you go to consistent PLS algorithm, again you see similar thing, but it's called consistent PLS algorithm and consistent PLS bootstrapping. Initially, PLS was developed to look at the measurement model which are formative, right? Formative. That means arrows are headed towards the other side, to the latent variable. But later, PLS was developed to have both formative and reflective, or together, right? Mixed one. But here we are having something reflective for the example, right? Activity. Therefore, I use not the normal one, right? PLS algorithm and the bootstrapping. I go to consistent PLS algorithm, right? I go to consistent PLS algorithm and consistent PLS bootstrapping. I go to algorithm first, right? I click on that. I click here, connect all the latent variables for initial calculation, right? Partial least squares, right? By default, these things are there. Keep them, right, as it is. That means stop criterion, right? Up to the very minimal points, up to the 7th, right? You can see here, right? The minimal value up to that point, they calculate that, right? Or either they look at maximum number of iterations, 300. Either, right, they consider, right? If whatever that comes first, right? Sometimes it can be this one that comes first, this criterion, stop criterion. Or if not, it comes to maximum 300 iterations, right? Only up that point they stop, right? This running of the algorithm, right? Remember, here there are weighting schemes, but since we need path model, you can select if you want path model. But if you are interested only in measurement model, you can select factor, right? Factor. But here I need both. I go for path. Then centroid means mean-centered approach, right? But usually we go for this path one. There are different reasons. Later you can read and learn, right? Why these things are there, right? In depth you want. Then missing values also, there are different treatments. By default, mean replacement is there. But there are other options also, right? Case-wise deletion, right? In the calculation, no pair-wise deletion, right? But I put by default mean replacement for any missing values, right? Weighting at the moment, we don't have any weighting factor, right? But in special cases, some variables can be a particular factor you consider as a weighting factor, right? For the importance. Yeah, you can select that, but here no need, right? Data groups we are not discussing just now, right? That is something which I created, but usually you don't have data groups there, right? Once you created only, you can have these data groups. Today we will try to discuss multi-group analysis or the categorical moderation. I think Alisa wanted to discuss that also. Later we will discuss that. Now my target.
Dinesh, now when there are missing values,
Yes.
now you told us that the software cannot identify the data set, no?
Yes.
Something like that.
Yes.
So then here,
it is
hello?
not shown. But in any case, if missing values are there, we can say that use this criterion. In any case. But sometimes when you have missing values, additional commas or something, you can't even see the data set. That problem is also there. That is, sir. But in any case, you can have a decision whether to replace the values with mean or any other criteria to skip case wise or something. You can give that one. But by default, we use the mean replacement. Then I go to start calculation, right? Once I have selected these things. Right. You can go to the PLS graph first. Then reports are also generated here, right? You can see PLS algorithm. Reports are here. You can see several reports are generated, right? You can see path coefficient, R square, F square, right? Then total effect, important, indirect effect, important for the mediation, right? Later we can discuss outer weights, outer loadings. Outer loadings, simply we say that the factor loadings. You see in other, maybe in SPSS you see factor loadings, or in AMOS you see factor loadings, right? The same thing, same concept is here, right? And also you can see the collinear statistics, right? Variance inflation factor is there, right? Sometimes we talk about the multi-collinearity issue, right? When two independent variables are highly correlated, there can be some issues in the model. Then you have to remove one variable, right? Therefore, even the multi-collinearity issue is predicted and can be, right, seen here. And you can see whether there's a multi-collinearity or not, right? Later we can discuss. I think this value should be less than 5. In that case, we can say that multi-collinearity issue is less. It should be ideally 2 or less than that. But you can manage if it is less than 5. But if it is above 5, multi-collinearity is there. That means two independent variables are highly correlated. That might not be good for the overall model, and there can be some issues. That is another thing you can see. When the discriminant validity you can see, right? And construct reliability and validity you can see, including AVG, right? Average variance extracted. These things are there. And also model fit indicators are also there. But first I go to the particular algorithm, sorry, graph, right? Now this is the graph you can see. When you run the algorithm, you get this one. You can see outside outer model or the measurement model factor loadings, right? Factor loadings. You can see factor loadings with different values. Sometimes you say that 0.5, some people say that 0.7 and above you have to consider. Others you have to delete and again rerun the model, right? Likewise, you are having much flexibility in this case. Like when you're having low AVG values, that means convergence validity, sometimes you can consider deleting some poor factor loadings. Let's say 0.511. Sometimes you can delete. Likewise, poor ones you can delete and rerun to improve the AVG level. Likewise, you are having much flexibility to improve the overall measurement model validity and the reliability, including the model fit indices. Then you can see each, like the contribution, right? How much each, what do you call this, indicator contributes to this particular latent construct or the variable. That's the meaning, right? You know, in normal factor loading side definition, you can see here contribution, right? Then you can see inside here, usually R square value is there, right? R square, that means the amount of variance explained by the independent variables, right? Amount of variance of a dependent variable explained by independent variable or the variables. Here you can see one variable affecting this one, that is only 21.6%. But here you can see two arrows are coming, right? It is something about 0.53% variance explained by CSOR and CUSL, right? In the performance, customer loyalty and the corporate social responsibility, something like that you can see. Here also you can see the particular values relevant to the factor loadings, right? These are the factor loadings, not the factor weights. There's another thing called factor weights that is applicable when the model is formative. Lalit sir.
Right.
Then you can see the path coefficients also. You can see the path coefficients. You can say simply like in a regression, you can see the beta value, something similar to that, right? This is the particular strength of the relationship. That means you can see CSOR, corporate social responsibility, positively influences customer loyalty. That is 0.465, right? You can interpret in other cases also, you know how to interpret that. The same you can follow, right? But the thing is now here you see on the algorithm. But the case now you have to look at even the significance level also. In that case, you have to go to not to the algorithm and go to consistency. This is reflective PLS bootstrapping, right? Bootstrapping. Then only you can see the significance values, T values, P values, and the other something relevant to the significance, right? Bootstrapping. Here by default 500 is there, but if you are running your final model, right, go to 5,000 at least, right? 5,000, that's a norm. Minimum 5,000 for the final model. That means you are trying to create subsamples from your data set of 99. You are trying to create subsamples of 5,000. 5,000 subsamples you are going to create out of the 99 data set. That's why this is distribution tree. Therefore, non-parametric requirements sometimes can be seen, right? Fulfill, therefore no need to fulfill the parametric assumptions, right? They create a distribution and they assume that it's like the population, right? They create a large population type distribution, right? Using this 5,000. That's a logic. We call this bootstrapping. You can click here, do parallel processing also. You can keep the basic bootstrapping, but if you need final model to get all the measures, you can click complete bootstrapping. Last time also I mentioned, right? By default, we say this is the one bias corrected and accelerated bootstrapping, right? As the advanced settings, but there is percentile and other different methods you can see. By default, two-tail one we go for, right? Significance level, if you want, you can change, but 95% confidence or the 0.05 level we look at, right? P value, probability value.
So Dinesh, now when selecting one tail or two tail, it depends on the way we have hypothesized, no?
Yes, sir, yes.
Directional or non-directional.
Yes, you have the freedom. By default, two tail is there, but you can look at your model and the way you have hypothesized directions, so you can change.
Right.
That flexibility is there. Then connect all latent variables, click that also, right? This one no need to change, as I mentioned, even for the algorithm also same thing is there, right? Maximum number of iterations and the stop criterion, right? Then I select path here, but if you want, you can select factor if you are interested only in the measurement model. But here we are interested in both Ultimately, we need the path inner model also. Therefore, I select this one. But this is also required in some cases, right? But in this case, we don't need factor, we need path. Then missing values, so the same thing you can see here. Weighting criteria, we are not looking at in this case. Data groups, later we will discuss. Then you can say start calculation. But when you have 5,000 or something bootstrapping, sometimes depending on your capacity of the processor, it might take time, more time, right, for the processing. But 500 you can quickly process, right? Again, you can, reports are generated. Now, two reports are there. Earlier you had algorithm, right? Now you're having bootstrapping. That is more relevant to the significance related, right, measures. Now I go to this one, the same model now in a different way. Now you can see path values as well as within bracket you can see significance value or the p value. If you want, you can change that, right? If you want, if you can have t values. If you want, likewise here, left hand side you can see, right? In a model you can show different things. Outer model also you can change, right? Weights or loadings with p values you can see, right? Even you can look at for the outer loadings also significance if you want, right? But normally we are not looking at, but in some cases you can look at if you want, right? That is generated. Now inner model I am interested in, therefore I go for path coefficient and p values both, right? Usually what you need in the inner model, structural model is this. You can look at the path coefficient, beta value, and the significance. Now in this case, when you look at the 0.05 level, all three paths are significant. No? These are 0. That means t value is anyway about 1.96. Sorry, t value. That's why p value is less than 0.05. Here also it's less than 0.05. Now, any idea? Now my interest is about here to look at the mediation. When you look at these three paths, what about your view? In a normal interpretation also, how can you say that? Whether there's a mediation or not? Whether customer loyalty mediate the relationship between corporate social responsibility and the performance. What's your view? Mediate tenwada nadda?
Is mediating.
Okay, okay. How can you say that? Yes. What's the logic?
According to the Baran and Kenny's rule, when the three parts are
That's nice, no?
significant,
Yes, yes, yes.
then we
Correct.
can say there will be a mediation.
Yes. Is it partial or full mediation?
Looks like partial.
Yes, this is partial. If it is a full mediation, there won't be this direct effect. That means we're having direct effect here. Corporate social responsibilities directly linked to performance. That is also significant. But if this is above 0.05 and this is also very poor value, sometimes in some cases you can see this is insignificant, direct path. In that case, always full mediation is there. That's a Baron and Kenny steps, but I think Nilakshmi, we can go to other one also, that is what do you call this indirect and the total effect. That approach also you can use. Some people are looking at that also, total effect and the direct effect.
So Dinesh, I have another question.
Yes. Yes, please.
Can you go to the model again? Now, earlier there was a figure for showing the variance, R-square values, but now in this model, we can't see the value. I mean, inside the blue node.
Yes, you can again run the model and sorry. When you run again, you can go to the original model. Now you can see this and you can try. Now you can't get both, right? Now you can get the path coefficients and the R square value. In some cases, if you want, you can draw the model right later, like maybe manually. If you need nice presentation with all these things, sometimes you can't get all these things, but when you run the, what do you call, bootstrapping, again, you can get the model with the p values, but they are, I think, Lakshmi, as you mentioned, R square value is not there, not shown. That problem is there. But you can quickly shift between the models.
Right.
Now you
Okay.
can see this one. But
Right. Okay. Okay.
yes, here you can see both now, but not the R square, path coefficient and the p values. In
Right.
this
Okay.
case.
Got it. Thanks.
There can be some limitations, like sometimes you have to manually draw and show the R square value also. But sometimes there can be in the professional version, sometimes you can see there are some more options are there, professional version. Now in the algorithm, I want to explain, I think, total effect and the indirect effect also. I think you can see indirect effect here. I'm looking at corporate social responsibility and relationship of it to performance. Indirect relationship is 0.113 and total effect is, I'm looking at CSOR to performance, not other things, right? I'm looking at the independent main dependent variable, that is, you can see 0.697. You can see. But if you want, you can again see this, right? Deleting one. I can delete this one. Again, I can run the model. I will go to consistent PLS algorithm. Now this is the total effect, right? You see that there, right? You also, you see the total effect, right? You can see that total effect. Again, I can undo and I can go to the original model. Now you can see this is the direct effect. Direct effect is 0.585, right? 585. Usually when you look at the mediation, you have to compare the total effect and indirect effect, right? Again, you can say that there's a mediator or not, mediation or not. You see here, right? You can see the total effect is this. And if you want to check that, I think you can, you know that you can multiply this path with this path. That is equal to 0.1 something, right? If you look at the direct effect. I don't know whether you can understand what I say. Some people might know that. When you multiply these two, that is really the indirect effect, right? That is shown here. You can see that that is around 0.1. Then 0.1, you can see that that's the indirect effect. Direct effect was there, 0.5 something, you can remember earlier. When you add those two, you get the total effect. I don't know whether it's clear. That is something not about PLS. I think that's something when we talk about this direct and the indirect effect and the total effect. There also you can see the mediation, right? When the indirect effect is there, you can say that there's a mediation. But sometimes the total effect is equal to the indirect effect. That means this path is insignificant. And there is no direct relationship. That means a perfect mediation. I don't know, Lalisa, it's clear.
Yes, Dinesh. That means if when there's a full mediation, we don't get direct effect figure, no?
Yes, that is insignificant
Insignificant.
and very, very poor value. Is it clear? You can try this simply, like, and you can multiply these two paths. Then you get this value, 0.1 something, right? In your records, you have it, right? In your reports, you can see this. On the bootstrapping, sorry, algorithm, you can see that, right? This value is coming when you multiply the things, right? When you multiply this by this, you get something around 0.1. Then when you add that to this one, you get the total effect. This is the direct path, 0.456 plus this path multiplied by this path, right? You have to add that to this one. Then you get the total effect. Total effect is simply when you run the model without mediate, you get that, right? It is something 0.6 something. You can see that, right? That's coming. You can simply do much flexibility is there here, right? That's the case. You can see. This is equal indirect effect plus direct effect. Indirect effect is 0.1 something. Total effect is 0.5 something, right? You can remember. Then you can see that it's a total effect. But in between, there is a mediating role of loyalty, right? But that is not a perfect mediation, partial mediation. That also you can look at, compare the total and the indirect effect. Or else you can practice Baron and Kenny's method also, right? That's something about the mediation, how to do the mediation. That interpretation idea you can master reading a research article, how to write it. That is how you do the mediation simply, right? You can have the full model and see the three paths. That is one approach, Baron and Kenny's approach. The other one is comparing the total and the indirect effect and the direct effect. I don't know whether it's clear.
I think it's very clear. So if anyone has question, you can ask.
Either you do AMOS or anything, that's a process in interpreting mediation, right? The basic inner model, right? I'm talking about the inner model, no?
Actually, Professor Dinesh,
Yes.
in AMOS, we do not multiply the path coefficients to find the indirect effect. The output straight giving us an indirect effect. And the total effect, how do we calculate? There is indirect effect plus direct effect is the total effect if there is a partial mediation.
Yes, but the same process should be working, no? Statistically.
Statistically, yeah, yes,
whether you
because
use
the value
regression,
is straightforward.
Yes, SPSS or anything, when you multiply indirect path, it's the indirect effect plus direct path, it should be equal to total effect. Yes, Lakshmi. But here you can see these two, it's I think how you report. Then that's about the mediation. If it is clear, Lalisa, then we can go to multi-group analysis. I think.
What about moderation?
Yes, I will come to moderation then first.
Right.
Okay.
So I think we have this problem because when I was trying to link these indicators to the model, then I noticed I have the same problem.
Moderator.
No, this 99 is too many, the same problem that others.
You are okay, sir?
No, because when I was trying to link these indicators, then I noticed. I also got the same problem. This 99 records, the problem that others reported.
Earlier, you didn't get that question, no? That issue.
No, because when I was trying to link this indicators, then only I noticed. Sorry for it.
There can be some technical
Others
issues.
also, I think, must be facing the same problem, I guess. This 99. Anyway, we can proceed with.
There can be some technical issues. I don't know. It works earlier, no? But in my case, it's working.
What about others? I don't know. If 2 or 3 reported the problem.
Ilakshi miss, did it work for you?
Actually, I did not try, Professor Dinesh.
Ashoka miss, did it work for you?
Dinesh, I use my
You are
data
having a
set.
different model.
Yeah.
Only also
Don't worry
the same.
then you can have your own model. I just want to show you these things. No? Therefore,
Yeah, I did what you have explained with my data set. No problem.
mediation, you are okay, no miss?
Yes, yes.
I think others, you can have your own data set and practice. If you know these steps, sometimes there might have been some technical.
It's not a problem.
Then Lalisa, I will go to moderation.
Right.
Then I don't have a good theoretically valid conceptual framework, but I have now independent and the dependent variable here. I assume there is another moderator, right? But theoretically I can't justify, but I will select, for example, I will assume this is competition or something, right? For the moment, there are 3 variables, what do you call manifest variables, right? 1, 2, 3, let's say the level of competition or something. Therefore, I want to get new latent variable created. I might say competition or something. I assume the level of competition affect this relationship, right? But remember that in your conceptual framework, moderation is usually shown having an arrow to the arrow, right, Lalisa? When you show that in a conceptual framework, moderation means with dotted lines, you put the arrow from moderator to the other arrow, right, which is linking the independent and the dependent variable. In a particular conceptual model, when you draw that in the report, that is understood, no? But in the PLS, you can't draw like that, right? That's the case. I don't know whether you understand that one. Now, if I show you something here, I can't show you that. Now it should be like this, no? Can you see this one? I'm trying to link this to this arrow. That's a moderation, no? When you show that in the conceptual framework in the report. Is it clear?
Yes.
But I can't draw like this. It's not working. See, I can't link that to this one. It is not possible. Therefore, I am trying to create an arrow from moderator to the dependent variable. Remember, that we have to do. This is a moderating variable, right? This is not the moderate effect. I will show you. First, I want to link these to the manifest variables, right? Then only you can see the blue sign is coming, right? In the complete model. With the shift, I select these, I drag this. Now it is completed. You can see this.
But it's same like independent variable, no?
Yes, yes. For the moment, it's an independent variable, Ashoka. Then there is another step.
Right.
Now, if you look at the clear process of moderation, we call that's the interaction effect. Mediation is intervening effect. Moderation is interaction effect. That means the multiplication. That means each of these independent variables, what you call indicators, to be multiplied by each of the indicators of the so-called moderator variable. you have to multiply each. That's why we say that this effect is in the conceptual framework we show arrow is coming from this moderator variables to the arrow that is linking independent and dependent. But when you draw the particular moderation relationship, you can't show that drawing that to the link, particular arrow, right, which is coming from the moderator variable. Now, for the moment, I assume mediator is also an independent variable. That's the first step. Even in PLS here, mediator is, sorry, moderator is also independent variable for the moment. First, you have to think moderator like independent variable. When you draw that, it should be like this. Second step is something like this. There is something called, you can see here, right? In the menu, you can see this moderating effect button is there. See, that is there. Then I want to create the moderator ultimately when predicting the dependent variable. My dependent variable is performance. I click on that. I don't know whether it's coming for you, right? Again, I will do that. Now I am having independent variable and the dependent variable. But in my model, this is the competitiveness is the particular competition is the moderator. But I can't directly link that to this arrow as shown in your graphical conceptual framework in your model, in your particular report. Therefore, first I had to treat what you call moderator variable also like an independent variable, right? Affecting the dependent variable. Therefore, I had to draw this one. Then I click the moderator effect and go to the dependent variable and click. Then it's coming this particular right screen you can see. Now dependent variable is given, right? Performance. You can't do any change there. Now there are two things here. Look at moderator variable is the one you know, right? In your model moderator variable. The other one independent variable, right? Now I had to do something like this. Moderator variable is there. You have to select the moderator variable. It's a competition, right? Not the CSOR, right? Competition. Independent variable also have to select, right? Okay. That is corporate social responsibility. Now I have to create the interaction effect. Now third variable we are going to create. Remember, that's a real moderating effect variable, interaction variable here, right? That's a technical process. Here there are several methods. One is the product indicator approach, right? That's a normal method for a simple model. That means, as I mentioned there, each indicator of the independent variable is multiplied by each indicator of the moderator variable, right? You have to do that for each and every one, right? It's a very, very painstaking and time-consuming task, but easily that is done here, right? It is automated, right? That process. Product indicator approach. Here there is another one, two-stage approach. When you go for higher order models, some special cases we go for two-stage approach, right? Next day, when we talk about the higher order models, we can discuss this two-stage approach as a practical way for higher order model Lalissa. Now, in this model Lalissa, I am having only first order construct. No? එක පැහැදිලිද දන්නේ නැහැ සර්. දැන් මට මෙතන තියෙන variable තුනම හැදිලා තියෙන්නේ directlyම indicators වලින්. දැන් සමහර models තියෙනවා second order නැත්නම් third order latent construct. ඒ කියන්නේ corporate social responsibility එක හැදෙන්නේ තව dimensions දෙකකින්. Dimensions තියෙනකොට dimensions හැදෙන්නේ තව indicators වලින්. We call high order models. කට්ටියට ඒක පැහැදිලිද දන්නේ නැහැ ලලිස්.
Oh, Hari Dinesh.
Like service quality, no? Service quality has 5 dimensions.
5 or 6 නේද මේ පරාසුරමාන්ගේ මොඩල් එකේ තියෙන්නේ නේද? එතකොට indicators වලින් හැදෙනවා 6 අර වෙන වෙනම හැදෙනවා ඒ ටික එකතු වෙලා තමයි large unobservable construct එක හැදෙන්නේ service quality කියන එක සර්. එතකොට when you are having something like that, sometimes we go for this two-stage approach, right? Here we call latent variable score approach is there, but for the moment we don't need since we are having first order simple model, right? Here there are some advanced settings as well, right? Product term generation. Normally we go for standardized one, right? But there are some other one also, mean centered and unstandardized one. But we go for this one normally, right? For special cases only we go for this one, right? Here also waiting mode, I go for automatic, right? But there are some other ones for special cases. But for a simple model, we go for these things. Product indicator approach is there, right? Now simply I have to create the moderate effect. Okay. Now you see new third variable is created. This is the interaction effect. Hereafter, we are going to interact the moderate effect by looking at the path coefficient of this one, right? When you run the model. That's the first step you have to do. Now, this is just an independent variable, right? Moderate. But we did something multiplying each one and created new latent variable. We call the interaction variable, interaction effect. If I want, I can show you this one. I can click on this and show indicators. Then you can understand how this is happening. Can you see that process is automated? Each of the independent variables indicator is multiplied by each of the independent, what you call moderator variables, what do you call this indicator. Is it clear? This is a simple interaction process. If you are doing manually also, you have to do this. SPSS multiplicative effect. That process is there, interaction effect. Is it clear? You don't have to do it manually. It's simply coming. Lalit sir?
Yes, okay.
You can see this. This is the technical process happening. Each one you have to multiply it by each one of the moderator variable. Then there's a new variable created. You can hide that, right? It's very complex. You can hide that. Now, this is the one we are going to work with, moderating effect. If you want, you can label that, right? You can say that interaction effect is or multiplied by, you can say multiplied by I think moderator variable is customer loyalty, no? No, what's competition? No, competition.
SPSS also now we can do using process the same thing, interaction effect.
Yes, Ashokamis. But it is complicated here. It's very simple process. Application.
Yeah, we can download macro and macro process, and we can do it easily now using SPSS as well.
Yes. Now here you can see the same thing is created. Now hereafter, this is the moderating effect, right? This is the moderator variable. But our thing is to look at how this is affecting this arrow. Come to this arrow, but that is separately created using this one. That is directed towards performance, right? Same effect is there. Now I have created the model. Now I have to simply run the model, right? We go to TLS algorithm. And I think by default, these things are there. I start calculating. You can go to reports as well, right? If you want later when you report, but you can see this here. Now, this is the one you are going to interpret, but my data set is not properly arranged for this sort of a moderation. Therefore, the result is not there, but you can go for bootstrapping also to see the significance also, right? Then you can see this is the you have to interpret, right? Now here there is no moderation, but you can see, right? It's a particular interaction effect path coefficient beta value 0.073, which is not significant, right? P value is above 0.05 here, right? Therefore, no moderation. But in any case, if you are having something significant, positive or negative, you can say that negative or positive moderation, right? That means the relationship between CSOR and performance is weakened or strengthened by this variable competition, right? Competition as a moderation. If you're having in your literature conceptual framework moderator variable, you can interpret accordingly, right? Whether significant or not. If significant, look at this direction, plus or minus. If it is plus, this is strengthening the relationship, right? Independent, dependent. But if it is minus, this is weakening the relationship, right? Remember that. Moderator can be something that strengthen or weaken the relationship, right? Therefore, you have to look at the direction, plus or minus, when you interpret. But be careful about that. Many people run the moderation, but the interpretation is imperfect, right? Samara kiyanna positive to negative the positive na make a sambandhe strong karna, right? That is there. Negative na eka weak karna. But you can look at the R square also, right? In different models, right? Before the moderation, what is the R square? After the moderation, what's the R square? That change also you can discuss, right? Now here it's not moderated, right? Insignificant. But in your model, if you have something like that, you can see. Further, you can go to reports also, right? You can see the R square values before and after. Lalisa, is it clear?
Yes, Professor Girish. Now, now this moderator variable is measured using interval scale now.
Yes.
In case if we have a kind of this kind like age or gender nominal scale, so what we can do there?
If you want, you can incorporate any variable as a independent variable or moderator in this PLS. Only thing is you can't have any of the endogenous or the dependent variable with categorical. Any other variable categorical, that means nominal, ordinal, interval, you can put as independent variables, so the exogenous variables in PLS. Therefore, you can. But my advice is, in this case, go to multi-group analysis. That's why when you're having such variables, better to perform multi-group analysis and see whether between age, there is a difference in the path coefficient for different age groups. You can nicely see that from the multi-group analysis, or we call categorical moderation analysis. Another term we say that. Multi-group we say categorical moderation analysis. Another term. Alice.
So that is what I wanted to know.
Yes.
Thank you.
Then I can go to that one also if you're okay up to this point. But anyway, don't forget to look at the reports, right? Algorithm, then you can see all the reports, right? Last time also I mentioned like these reports you have to look at. Discriminant validity we discussed last time, right? And also heterotrait, monotrait one, like latest one, right? In PLS, they say that it is better than Fornell-Lark criterion, right? Complex models, right? This should be less than 0.8, the correlation, then only performance, what you call discriminant value is assured, right? Therefore, you can see HTMT. Likewise, discriminant value, there are some alternatives. Even the, what do you call, call-into diagnostic, right? In red, it's shown that, right, 0.5 and above. Then there might be some issues in some variables. Likewise, you can see all these things, right? And some you can remove in that case, right? Using VIF factor. Then model fit also I mentioned, Lalisa, there are two models fit indicators. One thing is about when you look at the external outer model, measurement model, we have to look at what do you call this SRMR. That this is standardized root mean squared residuals. We say that this should be less than 0.08, but sometimes we say less than 0.8 is better, right? Saturated model for the outer model, Alice. But if you are looking at the overall model, goodness of fit, you have to look at SRMR estimated model, right? That is another thing. And also there are some other measures also recently they have introduced. In addition, norm fit index. This should be 0.9 and above in better case, right? Then only you can say that model fitness is there. Then you can see something related this goodness of fit. Recently, they have introduced in PLS. In addition, you have to look at the R square, F square, right? That is also something relevant to the overall model goodness of fit in PLS, not like in AMOS.
Now, when we have more than two independent variables, so there may be two moderating variables. So still the process is same, no? Testing.
Yes. Any number of moderators you can create. Very easy process is there.
Professor Dinesh, one more question.
Yes.
Now, when it is come to VIF value for collinearity, the threshold that we normally use is the VIF value should be less than 10.
Yes, some say better less than 5, but we can manage, as you mentioned, even between 5 and 10. Yes.
Now, in this case, I could see that values above 5 has been marked as red.
Yes. If you look at a lot of literature relevant to PLS, they say that they advise that better to have less than 5.
Okay, okay. Right.
Variance
Okay,
inflation factor. But sometimes you can go even beyond that, but there can be some issues in the final model in Lakshmi's. But PLS literature in many of the cases say 5, that even you can see it's
could be
red.
better.
Like.
Yeah, yeah. Right. Okay, thanks.
Then you can see outer weights also, but that is not relevant here. Outer weights are significant required, sir, when the model is formative model, right? In this case, we don't need outer weights. We are having outer loadings we are looking at, right? I think last time also I mentioned formative and the reflective. In PLS, you are having both options, formative and reflective. Then any questions about how to create the moderation again? I don't know whether you can remember that, right?
So I think we can move on to the next the group comparison or something.
Then let's say I'm having independent dependent variable. For the simple example, any complex model, you can do this. Now I'm interested in knowing whether, like in this data set, you can see I'm having some categorical variables. One is about service provider. I think that is measured using 4 or 5 categories, right? Type of service provider, service type 1 and 2, right? 2 different service type or something, right? Then for the moment, I'm interested in looking at service type. Or let's say service provider, for example, service provider, right? That is the particular variable I'm interested in. But in your case, it can be age, gender, some may be nominal, some may be ordinal, right? Categorical variables you might have. In this case, I have service provider, right? Then please look at, sometimes you might miss some steps, right? This what do you call multi-group analysis. First, I have to look at the data set, double click on this data set, right? Then you can see this, right? I have created something before this, I will remove that, then you can understand, right? When you go to the raw data file, nothing is there, right? Indicators, indicator correlation, the raw files are there. Nothing called data, what do you call this? Data groups are not there, right? Something like this here. Then look at here, you can see on the menu, add data groups, generate data groups, clear data groups are there. Can you see that there? These 3 icons you can see, no?
Yes.
I go to generate data groups. Now I am having a data set. I go to generate data groups. You can give any name if you want, right? I might say service provider or something, right? SP, you can write whatever things you want. Here there are different columns, but I select the first one. I go to this. Now I can go to the right indicators, right? In alphabetical order, you can see. Now my concern is about the service provider. You can see that they are no here in the list. Service provider, I might say there are 4 unique values, right? That means there are 4 categories, but service type only 2 unique values, right? For the moment, yes, I will select 4 unique values, right? I selected that one. Then remember here, there are 4 unique values are there, right? Maybe service one category 1, the other one 2. Likewise, you have given, right? For the nominal scale, you have given 1, 2, 3, 4 for the identification label purposes, right? There is no real value there, Larissa. Like gender, like, you know, when you say male, you give 1. When you say female, you give 2. Something like that, right? That's meant by 4 categories are there. Then you can specify this. Now you want to break them into 4 groups. 4 groups. But you can say that only create 4 groups and at least one group should have, right, 10. If there is no in one group which is not having 10, that is not considered. If a group can group 10ක්වත් ඉන්න ඕනේ group වෙන්න. දැන් මෙතන 4කට කඩනවා නම් group 3කට නම් ඉන්නේ 10ට වඩා එතකොට group 3යි හැදෙන්නේ ලරිස්ස. 4ෙන්ම හැදෙන්නේ නැහැ. පැහැදිලිද ලරිස්ස ඒක? මට ඕන වෙනස් කරන්න පුළුවන්. ඒ කියන්නේ මට ඇනලිසිස් එක කරන්න 10ක්වත් තියෙනවා. You can change this if you want. එතකොට මම කියනවා minimum cases 10ක්වත් තියෙන්න ඕන කියලා හැමෝටම. Right?
මෙතන service provider 4 types මොනවද දෙකස්?
Sorry?
මෙතන මේ 4 types මොනවද service provider?
Yes, this is the PLS dataset. Like you can say like it can be different type of maybe companies. Sometimes maybe I don't know, like government, private, or
But
maybe
for each case there should be minimum 10, no?
10. Companies 4ක් කියලා හිතන්නේ. Companies 4. පළවෙනි company 1 2 අර gender වගේ තමයි. Gender නැත්නම් age groups වගේ තමයි. එතකොට group කරන්න අපි යාට දෙනවා 10ක්වත් ඉන්න ඕන කියලා. නැත්නම් වැඩක් නැහැ කියලා analyze කරන්න. එතකොට මේක අපිට වෙනස් කරන්න පුළුවන්. If you want more, you can improve this, right? Then only there can be significant number of cases you can observe for the comparison. මේ ගොඩක් අඩු වුණොත් මම හිතන්නේ analysis එක සාර්ථක වෙයි කියලා. Therefore I give 10. Then I create okay. This is the first step, right? Now you can see my data set is 99. No? That is broken into 4 groups. You can see provider 1, I gave 1 to identify when I entered originally. 40 records are there, 40 participants are there, right? Responses are there out of 99. You can see likewise, right? Altogether 99 should be there. Now I created data groups. Method clear, right? This is step 1. We want to create the data groups. Sometimes male, female, and data groups they can method, right? Male, female. Likewise, you can have more groups. Then I go to this particular model, right? Model is there. Now I run normal PLS algorithm, right? As I did earlier, right? I run the normal one. Since this is the, consistent one, right? This is the latent one, no? I run normal way, right? Nothing new. But now you can see here, there's something called data groups created, right? Earlier, when you run anything, you didn't have this thing, right? Now you have created data groups, no? That's why that is added here. Do you see this? You have to select all. Remember this step. Now I incorporated them, right, into my normal analysis. Start calculation. It's like the normal process. Normal algorithm. Now I am having some reports. Later we will see the reports. I will go to the graph. Now you see this one, right? The normal model is there. But now you can see here on your left hand side, you can see under this calculation results, you can see data groups. This is a complete model. But when you want to see for one group, let's say group 1, that means the service provider 1, I can select that. Now you can see for that group path coefficient, you can see, no, that is different. Again, I can select service provider 2. Now you can see for that 30 or 40 group, different path coefficient la list. මෙතනින් අපිට බලන්න පුළුවන් la list වෙනස් කළ group wise. පේනවද?
Dinesh, can we see whether the differences are significant or not?
I will come to that point as well.
Okay.
මෙතනින් මම බලනවා නිකන් මේ groups වල කොහොමද වෙන්නේ? ඉනර් මොඩල් එකත් මට බලන්න පුළුවන් මේ. ඒ වගේ මෙතන දේවල් කරලා බලන්න පුළුවන්. path coefficients බලන්න පුළුවන්. Indirect effect එක බලන්න පුළුවන්. ඒ වගේ දේවල් අපිට වෙනස් කරලා බලන්න පුළුවන්. outer model එකත් බලන්න පුළුවන් මෙතන වෙනස් කරලා. නමුත් මෙතන මම බලන්නේ complete model එකත් මට එනවා right එක තැනක. මේ තමයි cases 99ටම run කළාම එන එක right. මෙතන indirect නෙවෙයි. I am looking at the path coefficient. You can see that. But when you change this, you can see subsample wise regression also, right? That means the path coefficients, right? That is there. Another thing is there, right? Highlighted paths. Use relative values, absolute values. දැන් මේක මට තව එකක් තිබුණා නම් පෙන්වන්න තිබුණා, right? ඒ කියන්නේ මෙතන පේනවා මේ ගොඩක්ම powerful path එක ගොඩක් highlight වෙලා පේනවා, right? With much density. සමහරවිට මේකෙත් එක පේනවා ඇති. බලමු මේවත් එක පේනවා සමහර ඒවා. ලොකු value එකක් තියෙනවා නම් මේක ගොඩාක් මහත් වෙලා පේන්නේ. දැන් ඔයගොල්ලන්ට මේක පේනවා ඇති මේකේ අඩුයි කියලා මේ. If you look at the
So what is the difference between that? They use absolute values and relative values?
Yes, simply sir, This is the thing. Absolute value means they are looking at simply the particular value of the particular coefficient. But if you look at the relative values, they are looking at out of all these relatively the size. That's the calculation. But normally we are going for the absolute values, right? Absolute values. But when you go for the relative one, they are looking at from the overall one measures how much proportionately each one represented. Then in a full model, you can see very one with much density can be more powerful. You can මුළු model එකම බලන්න බලන්න කොච්චර powerful ද කියලා. Path coefficients වගේ දේවල්. හැබැයි මෙතන බලන්නේ ඒ path එක ඒක තියෙන තැන absolute values විතරයි සම මෙතන බලන්න. මේක පෙන්වන්න පුළුවන් අපිට complete model එකක් තිබුණා නම් මේක පේනවා. සමහර ඒ කියන්නේ තව independent variable එකක් තිබුණා නම් සමහරට ඒකේ power එක වැඩි නම් මීට වඩා ඒක ගොඩක් මේ මහතට පේනවා සර්.
But Dinesh, these values won't change, right?
Now this is a complete one. No? Now I can change even, right? Provided to.
Yeah. Yes.
මේවා ගොඩක් පුව නිසා පාත් එක මේක අඩුයි. يعني යාගේ පාත් එකත් sorry this indicator loading also very poor. Likewise you can see you can show in a picture like which one is more powerful graphically. I think you can show that. If I'm having another variable, I think I can show you that. We go to this model, then you can see there are two variables. No? Data groups are there. Now you can see the model. It's a complete model, Alisa, and you can see absolute values. The relative values also you can see relative to other ones. They consider all other things and proportionally they present in the relative one. But normally we are looking at the absolute values, right? Absolute values. Now you can see different service provider wise also you can see, right? Different things you can further see this for the indicators also. Lalisa, this is step 1, but multi-group analysis is not yet completed. Are you okay up to this point?
I think so. No, for this.
Okay, now we have, yes, now we have created groups. Now when you go to calculate, you can see there's a multi-group analysis icon, right? Still we haven't performed multi-group analysis, right? Simply we have group and we have done the separate analysis. But in the multi-group analysis, I think Ashoka is also asked, how can we compare the significance of the differences between groups? It's like simply this one-way ANOVA or something we do in SPSS. No, you look at this group-wise means and something. Likewise, you get that report here, right? Even post-hoc statistic, everything you get here. Multi-group analysis. Now you can see here, right? Normal things you can see here, but under this setup, you can see now groups are there, Lalisa. Now, as per your interest, you can select. Now, I want to compare, let's say, service provider 1 with others. Service provider 2, 3, 4. Even others also you can add if you want, right? As per your requirement, you can do this. That means group A is compared with group B, right? If you incorporate anything group A, you can decide whether it's to be compared with anything, right? With group B, you can specify what you want as per your requirement, right? Start calculations. It takes some time, right? You're having a lot of calculations for this algorithm. Now, when you got these calculation results, you can see there are several, right? You can go to original model if you want, right? This is the multi-group analysis model, but you can go to the previous models also here, right? See, complete model, those things are also there. Now, the thing is here, there are reports. There are two reports. One is the algorithm. The other one is multi-group analysis. In addition to this, you have to run another one, that is bootstrapping, right? You want to compare the significance also, no? Right? You can run the bootstrapping also in the original model, right? But for the moment, I will go to PLS algorithm and also to this one, multi-group analysis. This is a multi-group analysis you have to look at. I think you are interested in this one, right? Here you can see parametric test and bootstrapping results and PLS multi-group analysis also. Now you can see, you can drag this and see clearly, right? Now group-wise results you can see here. Now I will take first one. Lalit sir, if I take the first one here, I'm looking at the path coefficient differences between service provider 1 and service provider 2. At a time only two things are compared. That means from the beta value of path coefficient 1 of the service, path coefficient of the service provider 1, right? I look at, from that I deduct the beta value of the path coefficient of the service provider 2. That is, this is the difference. You see there.
This is difference, no? Not the path.
Yes, difference. This is a difference. Likewise, for all the cases groups, you can see, but when you go somewhere, you can see the p-value also, right? Now, first you see the path values. Sorry, yes, path values. Then you start for the first path value, p-value. See, service provider 1 with service provider 2 different. This is a path value, p-value. Sorry, significance of the path value, right? But nothing is significant here. If you want to say that anything is difference is significant, this should be less than 0.05. Our normal p-value interpretation is there. For the second one, here second path coefficient difference, you have to look at the second p-value, right? That is respective to the second one. But this is not a good data set, but you can see, but anyway, this one is somewhat significant, no? You can see that. That model is corporate social responsibility affecting performance. In that case, only one is significant. I think that is the, but this is very complex, but as per your requirement, you can decide the groups also, right? This one, first, second, third. Third means here, third path value, right? That means 1, 2, 3, this one. This one. There's a significant difference for the path values of the service provider 1 and service provider 4 with respect to the relationship between corporate social responsibility and the performance. Only that is significant, right? Can you understand this one? This is the thing we call this multi-group analysis. Further, you can see parametric test also, right? Certain similar things are there, right? Path coefficient, then p-values, other side of the p-values, right? You can see p-values also, right? Sometimes the similar results you can see in these two as well, right? In addition, bootstrapping also there, right? You can see the significance values, but this is a very complex one. Again, I will do this for another one. We did this for, I think, service provider, right? Yeah, if I want, I can remove this one, right? The groups I created, I can remove here. Then I create new set of groups. I might say I'm interested in, now this is service type. Service type. Service type only two are there, right? Two values, two unique values. Service type A and B or something. Here you can decide whether 10 or right, more than that unit. There are two options are there, right? Now that is created. Now broken into two, right? 99. Service type 1, there are respondents 40. Type 2, 59. Like male, female, like, right? If you have male, female, you can break that, right? It's a very simple one for you to understand. Previous one was there were many groups. Now I have created the groups. Then you have to go to your model, right? Then you have to calculate. This is the previous one. I will go for new one, right? I can delete these ones. I go for normal calculation.
So here we do not need bootstrapping, no, to get the significance.
You can, sir. Then you can run that.
But with the first option, we get the significance values, no? This the cons.
If you are done once, it's there. If not, first time you have to run the bootstrapping. Then only you can get both. Now I'm having both. I can show that both you can see. At least once you have to run the bootstrapping for the model, then only you can have both in the model. That calculation should be there, bootstrapping. Now I can see both path values and the p values. At least once you could have run. Earlier I had run that. That's why. If not, you can see only the path coefficients without this t values or the p values. Then you can select here. Now I am having several models. You can see, like you can see here, complete model is there. Data group. I think I could not put that there, no, when I run it. Yeah, there's something new. I missed that. Select all. But make nothing in there. Select all, right? Now this one is created, no? After that, start calculation. Then only you can see group wise path also. I calculate bootstrapping also. Now here I am having complete model and the group models also together. Now you can see complete model when you go to the model. But you can see also, right, service type 1 path coefficients. Service type 2 path coefficients. You can see. But here you can highlight the path. We use absolute value normally, right? Now you can see absolute values. It's a complete model. Then you can see this path is more stronger than this path, right? Further, you can see service type 1. Further, you can see service type 2 also. See, this is more stronger part. since you can see, path coefficient is 0.7 something, this is 0.2 something, right? Which is not even significant, right? That is there. Now this is step 1, remember, right? Then only we are going to do this multi-group analysis function. First, you have to create the groups and run the analysis normally, both algorithm and the bootstrapping. After that, only you go for the multi-group analysis. Now you are having this thing, normal things plus group selection. I am going to compare anything in group A with group B. Let's say now here I am only 2. No? I select 1 here, the opposite one here. You have that freedom to decide, right? But 2 different things, no? I compare this. Start calculation. Now here also you have the things as you want, right? Results you can see. In the data group wise also you can see the results, right? Those options are there, but you have to go to reports, PS algorithm and the bootstrapping, and also multi-group analysis, right? This is more important, right? From this you have to report. Now see here, only 2 cases, no? You can see clearly here. Previous one was very complicated, no? There were so many groups. Now path coefficient difference between service type 1 and service type 2. If you simply look at the model also, you can see that, right? The difference.
So are we integrating which one? This parametric test or the first one?
Sorry, sir.
Which one we are integrating of this the bootstrapping or which one?
First thing is you can go to this one, sir. Path coefficient difference. You can see. This is for the original value, but this is for the, you can see the calculated values, but you can see for the original value. But here better to go to parametric test. Parametric. Then you can see path coefficient differences, and also there are respective t values and the p values. Normally we go for parametric test. When you go to bootstrapping also, you can see the same values, right? Now look at path coefficients. You can compare that here, right?
So in reporting, we report this parametric figures only.
Yes. Parametric ones, you can see the p values and the path coefficient together. Since you have to look at the significance also. Now this is a model 1 path. You can see. I'm looking at competition affecting performance or something. 939. Then 2795. You can see that difference here. That's a different list.
Right.
That's a difference, and you can see the p value here, right? Not significant in this case. That means between the groups there is a difference here, a small difference, but which is not statistically significant. If you're having overall hypothesis like service type may be affecting the particular relationship in the model, overall hypothesis is, I think, not valid, right? Since we are not having enough evidence to reject the null hypothesis, saying that here p value is less than 0.05. This is not significant. Alisa, when you go to parametric and PLS group also same values are getting here, right? About the difference.
So that's why I asked only which one we need to interpret.
You can go to MPO, even parametric you can report, since like you are getting the same values. Ultimately, that is based on these bootstrapping results.
Professor Dinesh, now it's 9:10. So
Yes, sir.
can we have another session? We have another one. We can have another one on this higher order one model, no?
Yes, I think basic process, I think you are clear with, no? Like further you can read the articles and see even reporting also, there is no consistency sometimes. Some people use certain measures, like here is still growing them, but do not like AMOS. Therefore, different groups argue different things. Therefore, you can see the particular practice and the literature, they are how they are arguing, which measure they are using sometimes, and see the most acceptable and the what do you call practically argued one in sometimes you can see, not like other well-established AMOS like models. Here still there are different arguments, right? Therefore, you have to back by some of the literature by different groups which are acceptable, right? When you report the PLS, not like other ones. Still argument is developed, Lalit sir, some of the measures and analysis.
Okay. So we will have another session, next Monday to complete the remaining stuff.
Higher order models we can discuss.
Yeah, high order, yes. And also if we can run another bit more complex model with this group analysis, I think that would be, you know,
Yes.
useful, and we can remind again next week, and then we can move on to this high order model.
Yes, we can do the high order ones.
Yes.
Yes, high order ones, and also this what you call how to calculate moderation in that case. Those things we can do again.
Yes. With a bit complex model, no?
Further, you can read and learn like and see how they have reported. I think in reporting also sometimes there are different arguments. That's why this is not still established, still being developed, but there are a lot of practical and applicable techniques are there compared to some other software analysis. That's why I think it's getting more popular and practical and good for exploratory type models. That's why I mentioned that. Not like
it's really important for countries like ours, no, because we can't have this normal sample, you know, the sampling problems, random samples,
formative type measurement models. Then for the day we will conclude. No, Lalit?
Yes. Then if any questions from the audience, or otherwise we can adopt the session and we can have another session on next Monday to conclude the series.
You can again practice this one, right? Your own data set and see, right? Mediation, moderation, direct, indirect effect, and also multi-group analysis.
Dinesh, I think now, before 2-3 years ago, now smart PLS have so many improvements. So
Yes.
earlier, yeah, once we are starting this type of things, we haven't had this much of facilities.
Yes, still being developed, but now, yes, within last 3 years, there are significant improvement in the software.
Yeah. Even now, there is a latest version, right?
Yes. Latest one, professional one, I think you can see. I think I emailed that one, professional version.
How much that cost?
I don't know. So you have a big amount. Sometimes weekly
about
also.
200,000.
Sorry?
200,000. Around 200,000, but with the dollar fluctuation, I
If
don't
we
know.
can this,
$1,000.
no, if
200.
we can get 1 or 2 licenses to our research center, because we are going to have in vivo 2 licenses, like if we can get 1 or 2 licenses of a research center, then everyone can use, no? Anyway, we'll ask the dean to consider it.
Universities, I think academic version is there, no? You can buy this, I think,
Yeah.
group license or something.
Anyway, then thank you, and Vilani, can you conclude the session?